Today I'm going to turn this transformer into an autotransformer. Now an autotransformer only has one winding. I know that this transformer has two windings, but I'm going to connect the secondary winding in series with the primary winding. If you want to know about the rest of these numbers, you can go back and see my last video. So what I'm going to do is connect one leg of the secondary to one leg of the primary, and then I'm going to connect a load across. So here's how it's going to work. On the primary side, I'm going to connect a lot of windings directly across the supply, active and neutral. I'm going to connect the secondary of the transformer in the same direction, and I'm going to connect the supply. So on the primary side, I will have 240 volts. On the secondary side, I'll have the 240 volts plus another 30 gives me 270 volts. So let's see what happens. Now I've connected the primary winding to the secondary winding. On the primary side, we have 240 volts. On the secondary side, we have 30 volts. If I add the primary to the secondary, I end up with 270 volts. Now doing this, you need to be a little bit careful, because if I connect this one backwards, the 30 volts will subtract from the 240 and I'll end up with a lower voltage out. It might help to think of it like this. When I apply a voltage to this coil, it's generating a back EMF that is equal and opposite to the applied. So that induced voltage that's being generated, in this case, is assisting what's being applied. Here's our applied, here's our opposing, going this way. So what we're looking at here is the voltage that was induced into all these coils, the voltage that was induced into these coils and the voltage that was induced into these coils. They've been added together to give us 270 volts here. If I switch these around the wrong way, it might help to think of it like this. This is essentially the same drawing, except that these are in the wrong direction. So what's happening is voltage is applied to these. That induced voltage that's going back this way, on these ones is going this way, cancelling out the effect of all these turns. So although I've got the two windings connected in series, I'll end up with a lower voltage here, 210. Just for the fun of it, let's have a look at that. I've now changed the connection of this neutral terminal, and the voltage induced from the secondary is in the opposite direction. So my voltage from the output will be brought down, 210 volts. Let's put it back to the way that it should be. Now to see what happens with the current, I'm going to connect this little mixer. It's just a cheap little mixer. It'll give us some kind of load, and we'll see what happens with the current in this circuit. From the supply, I have 550 milliamps. 550. Going to my load, I have 430. Through the primary winding of my transformer, I have 150. What I had was 550 milliamps from the supply, from the 240 volt side. I had 430 milliamps on the secondary, on the 270 volt side, and I had 150 milliamps in the center. This is a 100 VA transformer, and the primary can take 0.3 amps, so we're only using half of the current that's available to that. So what we've managed to achieve is by increasing the voltage on the secondary side, the current was reduced. Magic! In the centre of the transformer, the primary winding, the one that had the smaller cross-sectional area, we were down to 150 milliamps. Let's do some quick numbers for this side. 240 times roughly half an amp equals approximately 120 watts. And on the secondary side, 270 volts times 430, 116. So approximately, these are rough measurements, so approximately the same power in as we got out, and the primary of the transformer was using minimal current. So the reason I've told you this story is to let you know that a simple transformer can be used as an auto transformer to either increase or decrease voltage. Buck ya!